This is episode number 40 of DevOps Paradox with Darren Pope and Victor Farsick. I'm Darren.
And I'm Victor.
Today we have a guest with us. His name is Eric Mizell. Hey, Eric.
Hey, how's it going, Darren and Victor?
Good. So in full transparency, Eric and I used to work together 8-9 years ago. It doesn't seem that long.
Yeah.
We were actually talking yesterday. It's like, hey, can we reschedule this recording? I got to take my son to get his permit. And the last time I remember your son, he was maybe 4.
Yeah.
So 4 or 5. So it's been a while since we actually seen each other.
Yeah.
Eric is the VP of Solution Engineering at OverOps. We'll talk more about OverOps later. There will be a shameless plug, fair warning, but not until later. His title isn't as long as yours, though, Victor. Your title's still the craziest.
Yeah. When you're not sure what you're doing, you need to invent something so that nobody really knows what you're doing.
I like it.
Maybe we need to do that. That's what we'll talk about on the career episode once I get that guest. That's going to be pretty good. But anyway, Eric's with OverOps. He came up through the world pretty much like I did. I was looking back over your bio. You had Power Builder there.
Yeah.
Oh my gosh, Power Builder.
That's where I cut my teeth, man. Power Builder.
Did you cut your teeth or cut your hair afterwards?
Yeah, we can see from my hair, but no, I cut my teeth on it. Data windows, craziness, fat clients. But thankfully got into the world of Java and rewrote the whole app in Java and never left that Java world since.
Which is interesting because we talk a lot about the DevOps stuff here on this podcast. And one of the key words is always continuous. Of course, we have the new course about Canary deployments on Udemy. Again, shameless plug. But Eric has coined a term that is another continuous term that I think is really interesting, and it's continuous reliability. Explain to us, Eric, what continuous reliability is or what it should be.
So first thing, I'll give you a quick backdrop. As a software engineer, the biggest challenge is trying to deliver quality code across a continuum of, as you're developing to QA to production, with different types of testing, static, dynamic, you're running, load testing, et cetera, and manual testing. And in the new world of CI/CD, where we're trying to move faster to keep up with the Amazons of the world, the Googles of the world, where these guys are new school and they deliver or deploy code hourly, minutely, right? Like they're constantly deploying code. How do I move to that world when I'm coming from a monolith where, or heavier code bases where I deliver code every 6 months or every 3 months to a notion of delivering every other week or once a month? Like for some folks, they're struggling just to get to deliver once a month because they're used to every 6 months. How do I get there faster? And so this notion of continuous reliability comes up where I need to move faster. I need more automation. I need better tooling. I need better feedback loops, and I need more automated processes. And so I do a lot of talks on continuous reliability because what's happening is you kind of have this notion of a Venn diagram of where I have speed, which is how fast can I move, or how fast can developers deploy or develop code. I have quality, which is how good or reliable is my code, and I have complexity, right? So this complexity says, how complex is it? We're moving to microservices, which is by far more complex than a monolith, but yet easier to maintain. So I look at that Venn diagram and I just look at it, there's no way to really get all three. Because if I have a complex product, I'm going to give up speed. If I want higher quality, I'm going to give up speed. There's trade-offs to all of these things, right? If I want to go fast and I have high complexity, quality is going to suffer. So this notion of continuous reliability is how do I get to the middle of this Venn diagram where I can deploy code faster, I can have better feedback loops, catch errors sooner in a shift left world. And I'm sure you guys have seen a lot of shift left. And we want to catch the errors before they get to production. There's a lot of talk about, I need more code coverage. I need, better testing. But the reality of it is code is never really tested until it gets to production. So you get this vicious cycle of how do I get those test cases back into into my QA cycle and move faster. So the way I see the world changing, first thing is automation. I think we're all seeing that, right? More tooling, more automation, and less reliance on humans. I hate saying that, but it's reality. The more human intervention in this pipeline, the more chances for failure. So think of manual testing. Someone does a test case, they miss a step, they pass it, it fails in production, no one knows, right? Less reliance on logs, if you will. Everything goes in a log. And the problem with a log is it doesn't tell me anything proactively. It's reactive. So I need more things monitoring live running apps, live running tests. So I like to call it AI, or code monitoring code, giving me better insight. I guess I'm going too much here. I should probably stop and take a break on this and let you ask some questions. But this notion of automation, getting a shift left world, getting things sooner before I get to production. And then if it gets to production, having a way to detect issues faster and get it back through the cycle faster in that pipeline helps me move really, really fast.
I think that the last part is the crucial. I think that most of the companies throughout the history of software engineering was focused primarily how to make something not fail in production. That's why we would have like a year-long cycles, kind of like, I need to spend months and months and months because when I put it to production, it's going to be rock solid. The part that I was always curious about that theory is that kind of like you would fail every single time and you would still think that makes sense to continue. But if you have that attitude, I'm going to make it work no matter what in production, then whatever you just said is useless.
Right. And to your point, the notion of when I used to write software, we were going through the same model you're talking about. You think of every permutation that could break the code, and you spend weeks on this and months with testing and retrying and experiments. You don't have that time anymore. The product has to get to production. Business doesn't wait. We're competing with so many other, you could start a company. The three of us today could start a company today, right on Amazon, and we could have something spun up and be competing with somebody in a week. And when you're talking about new school development and you're moving faster versus someone who has legacy, they move very fast. We have to change our mindset and how do I move faster, but have a way to catch the issues in the code or the issues in my pipeline, whether it's database, middleware, whatever, before it impacts my customers without having to take the months of time it used to take, to your point.
I don't believe it's not even only about speed. I would actually say that even being faster comes later. First, I think that we need to abandon the idea that you're going to, no matter how much time you spend, a day or a year, you're not going to make something that works in production from the first attempt 100%. So it's not going to happen. It never did. And then once you accept that, and that's my belief, then yes, we are going to deploy to production. It's going to fail. So why not at least go faster and in shorter iterations? Then at least we can control the scope of that failure better.
And that's interesting. I think that's where people are getting into the microservice world, where I'm making smaller incremental changes faster, right? To your point, where I can move faster, more agile. My biggest piece of this is knowing. This is where I struggle. Shameless plug. I've been working as a field engineer for years, and I work with a lot of companies. And most people don't know when a new error happens. And that's my problem, right? So I'm moving fast, and I'm going to accept this model that I'm going to break things. It's okay. But if I don't know things are broken, then it's impacting my customers. And that's where the pain starts. How long can I tolerate that from a business? That's where I want something monitoring code, shameless overops plug. It detects new errors and will tell me right away. And if I can know right away, I can fix them and I can move faster. Hey, look, I saw the problem, fix it, deploy, fix, deploy. And that model keeps me moving faster. To your point, helps me not to have to spend hours and hours ahead of time.
One of the big changes I think about monitoring in production is that in the past, users were monitoring production. You would find out that something doesn't work because a user would call you kind of like, this doesn't work. And then you find it out. And today, users don't do that anymore. When it doesn't work, they go somewhere else. You never find out from users anymore that there is a problem. They're somewhere else.
That's exactly right. I got to give you a hilarious story. And I can't make this stuff up. So my wife was trying to buy something on a website, I won't name the website, for Cyber Monday. And she puts everything in her shopping cart, hits buy, disappears, nothing. So she does it again and nothing. And to your point, two types of people in the world. One calls the call center. That's my wife, a little old school here, right? She calls their call center and orders the stuff. The rest of the world goes away, never comes back to that company. Both of them cost you money because one, you have to have a call center person to take the call, or you lost business permanently. And then they tell 100 people, right? And the sad part is nobody knows. Nobody knows unless someone complains. To your point, nobody knows. It's an abyss.
That's always fun. But then when the failure occurs, when you've learned that new error, what have you seen? Again, not a pitch for overops, but it helps in this space. For people that actually drink that Kool-Aid and do it, do they actually do the work? Are you seeing people actually, hey, this error just happened, let's fix it and let's deploy it? Do you see that happen enough, or is it still, oh yeah, there's the new error, okay, it'll go out in 3 weeks?
No. So what's interesting about overops is we actually give you the business context, right? So is it happening in a business transaction? I think that's what I've learned heavily in this last few years I've been doing this with overops, is that people in operations need business context. If I have an error, what does that mean? What is it impacting? Nobody knows until someone complains. That's the notion of it. You know, is it a database problem? No one knows. But if I can tell you that a payment transaction is failing, then that becomes super interesting, right? So if I'm sitting in the ops desk and shopping cart purchases is failing, and you get an alert that says that, that's going to catch your attention. That's the type of details we give you. And so that's what gets people's attention, because that becomes a P1 versus the noise of errors that you get. When you think about how people detect errors today, most of it is volume-based thresholds. And they just get bombarded with alert storms. It's kind of like the notion of a car alarm going off. No one cares anymore. So it gets ignored, to your point, Darren. So we want to make sure we give data that gives high value context related to something business related, so that it's human readable, and that someone who's at an ops center can go, oh my God, this is, shopping cart, or this is payment, or this is open enrollment, or whatever it might be that's important to the business that demands attention. And we give you a root cause screen that actually is something you can triage in minutes versus shifting through logs for hours.
Maybe it's also about limiting scope, because that reminds me in a way of testing. You know, when you run automated tests, and then when you have situations where tens or hundreds of tests are failing,
Mm-hmm.
and then you just say, yeah, tests are failing.
Right.
What can I do? It's tens of them. But if you get to the point that a test fails, a single test fails, at least psychologically it's different. Oh, okay, so I have a test that needs to be fixed. I can do that.
Right.
When you have 100 tests that needs to be fixed, then you just give up. I would give up.
It's funny you say that. And that's one of the things that has been foremost what we're hearing from our customers and from analysts and all these the folks that we speak with. But everyone has accepted technical debt and legacy debt. Your application has tons of errors. To your point, thousands of these things fail. Oh, well, no one's complaining. That's the answer, right? What people don't want is the new issues or the critical. So we have a way to tell you what's new, what's critical, prioritize them. So to your point, when you run a test, if I'm a shift left, what do I care about? I don't care about the tens of thousands of problems I've had for years. Don't have time to fix them. No one's complaining. I reboot. I have to say this is sad. And Darren knows this story because we lived it at Terracotta. I reboot my server every night when it has a memory leak. That's how we solve it, right? We've accepted that. What we don't want is we put this new feature out that causes us to not process a payment or causes us to lose financial whatever. That's what we want to focus on, is those types of errors. That's what the focus needs to be. Continuous reliability. If I'm going to move fast, I want to know the new features I'm building and the functionality I'm changing doesn't cause me financial pain or cause me to lose customers. And if I can identify those over the technical debt, life is good.
It's kind of like I acknowledge that I have technical debt, but at least I can work on not increasing it.
Correct. And then maybe burn down if I can troubleshoot faster, because I have a root cause screen that shows me the actual problem versus sifting through logs. Then maybe I can start burning down technical debt in a sprint.
Cool. And we got a puppy today. Who's the puppy? Is that
That's
you
my
or
puppy?
Oh, it's your puppy.
About that.
Okay.
Yeah, my wife
No, it's
had to
okay.
have one of those, so here we go.
Well, mine is sitting over here quietly behind me for right now, but at 70 pounds, he's not such a puppy anymore.
No, I would think not.
He thinks he is. Again, we're off on a different topic that has nothing to do with DevOps. We're talking puppies. As long as we don't have kittens. Of course, Victor is the one that has the cats. I'm surprised I haven't heard him crying today. There was one episode he was crying a lot, but that's okay. So technical debt. All right, so let's ask this sort of in a generalized way here. In the people that you've seen, whether through OverOps or other places, is technical debt really a big deal? People say it is, but what do you see? We probably have a big overlap in client sets, but bottom line is, do you see people really caring about technical debt?
No, unfortunately, I don't. And it's funny you say that. When I first joined here 2 years ago, my mantra, my stick, is I'm a software engineer by trade, is to not have technical debt. And I wrote a blog about changing the status quo and why is it acceptable to have all these errors, which no one cared, right? Because the facts are the facts that business moves fast. These VPs of engineering have, tens of hundreds of developers, and they have feature requests and things they have to build. And the technical debt is technical debt. And so what they've chosen to solve it with is, like we mentioned, reboot my server every night because I have this critical error. I have customers that reboot every 4 days because at the 5th day, everything crashes. So to avoid it, we just reboot. We have people that have, we're going to do Canary deploying because Canary helps me roll back. There's all these different ways. Like I had a customer asked them, how do you solve for these problems? Oh, well, if the container dies, a new one spins up. Yeah, but your SLAs go for a toss while that container's dying because, memory's churning, threads are locked, whatever. And they're like, oh, I never thought of it that way. So to your question, no, people are not solving technical debt. They're very focused on new features because they have to keep up with business.
I think that there is another problem, and there are many other reasons actually. I think it is that many people don't have a valid point of reference. It's kind of, on average, it takes us 3 months to release a new feature, and that's normal because your only point of reference is yourself.
Correct.
I think that it's our obligation in a way to kind of show people that, no, that's actually not the reference. The reference is that, and it's this, and you are there.
Mm-hmm.
Once they realize that, then the technical debt becomes a thing. Oh, yes, okay, so that's how normal looks like. And that's why technical debt matters, because we cannot be normal. But as long as you think it's normal to release once a year, then why would you fix technical debt? You're within the boundaries of normal.
You're absolutely correct. It's what people are used to. It's what I call the status quo. This is what we've had. This is what we accept. This is how we do stuff, how we've always done it, and it's fine. And to your point, needs to change. I'm actually starting to hear error budgets coming up with companies and technical debt burn down budgets, bug bounties. They pay them to come in on a weekend, and for every bug they bash, they get a little stipend or a little perk, right? And so you have to change the way you think. And those things, everything is a cause and effect. If I fix all of this technical debt, guess what? I don't have to reboot every night at midnight because of a memory leak. So I fixed it. These deadlock issues or the thread problems or my database index problems go away if I fix them. And guess what? Cause and effect, everything runs better. My SLAs are met, applications run better, less headache for everyone, less Sev 1s. The other thing I love is less in the logs. So what kills me is logging has become our hammer, and every problem's a nail, and we throw everything in the logs. And when people have issues, they go to the logs. And we used to do a query for a timeline, and that timeline now has 10 million entries because there's so much in there because we've accepted it. Can you imagine if you cleaned it down and there was only 100 entries? Boy, you could find stuff fast, right?
Let's go back to your earlier comment real quick. And I'll say it this way. We are trying to eliminate the humans as much as we can.
Not eliminate, sorry. To move humans to do something else.
Well, it gets back to budgets. Maybe it is eliminating the humans because it gets back to the automation, right? How much of this stuff is reallocating people to the correct place? Some people will get scared because their whole life the only thing they deal with is going through logs and finding errors.
Mm-hmm.
Right? That's their job.
Correct.
That's what they believe their job is.
Mm-hmm.
And they're scared to make a change.
There's always that who moved my cheese, right? Or changing, to your point, this is my job. And I'm like, when I said eliminating humans, what I meant was eliminating the human factor. So let's play this scenario out. You guys release code to me. I'm the QA manager. And today it's my decision to decide to promote the code. And we run all of our manual tests. And I'm like, yeah, it's good to go. I made the decision, and the decision is based off of what I know, which is I queried the logs, I grepped, I did this, and it's good. But if I could have automation and quote unquote AI tell me, hey, in this release, after all your testing's done, you had 3 new errors, 12 critical, and then 50,000 technical dead errors that we all know about. I have a better lens of making a decision. It's not the human decision of this is the status quo and it's okay. It's, hey, here's subjective information that tells me, should I promote or not? Because it analyzed my code at runtime and told me, should I promote or not? That's what I'm talking about, is let's give the humans better tooling that tells them, hey, what does that release look like? And I'll give you the 2-second, probably more than you want to know, but part of my past career, I was working with an offshore group and they kept giving us code that was more broken than fixed. And so we decided to back charge them for every error they created. And so we got the next release from them, and guess what? There was no errors, not one. And my QA team was like, yay, everyone's applauding. And I'm like, how can that be? But I didn't have time to look at it because I had so much to deliver. So we released the code, and I got the first call, and this went to big insurance companies. Get the first call probably an hour in, and they're like, nothing's saving to the database. I'm like, what do you mean? And they're like, well, we went through this whole new wizard feature you guys built, entered all this data, and nothing saved. So what we found out is the offshore team was swallowing the exceptions because they couldn't get the inserts to work into the database. So instead of them turning in code that has errors in it, they turned in code that has none, but didn't work. We had no idea. It took us 2 months to unwind. All the swallowed exceptions, easy to find by searching and going through the code. The problem is we had to fix all the code. It took 2 months. So this is what I'm talking about. Illuminate that human decision factor by giving really good information that detects all these issues and tells me. It's a big change.
And if there was only a tool or a service that did that for us.
Wouldn't that be great? Overops. Overops. That'd be awesome.
So give us a 31-minute pitch on Overops. What's its scope? Because I've looked at the site. In case you're listening, it's overops.com, overops.com. It looks like it's primarily Java. Is it only Java?
No, so we're Java and .NET. We just released .NET, so to be fair, that just came out. We'll be announcing GA of that here in another week or so. But yeah, so the scope of Overops is about identifying, prioritizing, and resolving your most critical exceptions before they impact your customers. So we're a runtime agent with no code changes, no configuration. You turn it on, it automatically does all this magic I've been talking about. The idea is to be able to automatically detect all these critical issues, whether they're then something even that doesn't show up in a log. So like a swallowed exception, unhandled exceptions, help you prioritize them, categorize them, tell you what's new, what's critical, what's resurfaced, and give you a proper alert with context. And the context is something that no one's ever seen before, something I would have loved to have when I gave you that example of this offshore group with swallowed exceptions. We actually will show you source code and all the variables that were moving through the system at the time of the event, and it helps you to triage and troubleshoot problems in a fraction of the time. So I'm not diving through logs, looking at stack traces, trying to figure out what's happening. I'm actually looking at what we call a snapshot of the error at the time it happened with the source code showing me exactly where it failed and all the data. And data is usually about 90% of why the errors failed. It was something we weren't expecting. And now I have all that context. I can solve the issue quickly. So that's that notion of identify, tell me what's new, critical, whatever, and prioritize it. What's the most important ones, and then resolve it. That's what we do.
Yep. And it's a SaaS, I would assume.
We're SaaS, on-prem.
On-prem.
Yep.
Okay.
Either
one. Cool. All right. Well, Eric's information will be down in the show notes. His LinkedIn, his email, his bank accounts. And there will also be a video from DevNexus that he did back in 2019. 2019? Yep. Is that when it was? Okay, 2019. Talking more about continuous reliability. This is one of his, much like Victor is all about Kubernetes and now Canary. Another pitch for the Udemy course. Still on sale. Hurry up. That coupon expires in 2 days, I think, or 1 day. Or did it already expire? It already expired, sorry. There's probably another one coming, though. It's continuous reliability is what you're all about right now.
Yeah.
So all of his information is there. If you're listening via Apple Podcasts, please go ahead and subscribe, leave a rating and review. All of our contact information, including Twitter and LinkedIn, can be found at devopsparadox.com/contact. New thing. Actually, 2 new things. If you'd like to be notified by email when a new episode's released, you can sign up at devopsparadox.com. The sign-up form's at the top of every page, pretty much every page. I think there may be 1 or 2 that I missed. And finally, we have transcripts now, thanks to the wonders of AI, because there's no way I could type out everything that we do. They're not perfect, but the transcripts are also going to be on the page at the episode link at devopsparadox.com. So like if this is episode 40, so when you go to devopsparadox.com/40, you'll scroll down and you'll see the transcript from today's episode. And for pretty much every episode this point forward. Whether or not we go back and do the old ones, I don't know yet, but maybe. Anything else from Victor? You don't have anything, right? No? Okay. You're good. Eric, do you have any final words you'd like to say before we cut you loose?
Yeah, just thanks for having me, man. It was good chat. Appreciate the time. It was fun.
Yeah, man. Appreciate it. And thank you to listening to episode 40 of DevOps Paradox.